going to call this section 4.8b, even though it's really kind of its own topic. We're going to take a little time to revisit the idea of piecewise functions. And we're going to do it now from the perspective of we have a lot more functions to think about than just the linear ones that you worked with the last time you talked about piecewise functions. So we're going to try to build a piecewise function reflecting this data here, using any of our polynomial functions that seem to fit well. So I'm looking here at this data that shows, let's see, for various years, this is showing the worldwide tablet shipments starting in 2010, right? So you can see lots of tablets being shipped, they declined for a while, and then in 2020, we have an increase in shipments again. Looking at this graph, for a while, it really appears to me that we have data that looks like it's a pretty straight line through here. So I would be tempted to say I think I could model the data with a straight line for those first few years, up to 2013, let's say. After that, clearly it's no longer linear. In fact, I'm seeing a bit of a curve here. So I'm going to just kind of sketch in what I'm seeing. I'm thinking maybe I'll use a linear function from 2010 to 2013. Now after that, let's see, let's just play around with this a little bit. If I kind of follow that, well, let's see. I've got a function that's going down to the left and up to the right, and it's got two turning points. That reminds me a bit of a cubic function. Odd-powered for sure, since down to the left and up to the right. But the two turning points make me think maybe cubic. Now I won't really know until I try my model to see if I get decent correlation coefficients. But if I do, I might be able to make a two-piece model, one linear, one cubic, that will reflect this data pretty well. We're going to give that a try. I have already pre-entered the data into Desmos for us. So you can see over here in my Desmos table, my first table for the years, and I am letting T, by the way, be years after 2010. So this would be the years 0, 1, 2, and 3 that I'm including in my linear piece. And then I'm just put my Y values in, starting with the 17.4 and so on for those first few years. And then you can see the second table there. I'm using the third year as the overlap year. So I've started with year 3 and then gone out through year 10. And I've entered all of the shipment values for those years over in my table. So my first table is the one that I'm going to try and make a linear graph out of. The second one I'm going to try and make a cubic graph from. Let's see what we get. First of all, I'm going to turn on my linear data so you can see it. And even when I graph it here, it definitely looks reasonably linear. So we want our model to be y1 tilde mx1 plus b. Right? And looking at that, I have a great fit. R squared is 0.99 something. And they've given me the slope and the y-intercept. So, just for my own use, I'm going to write that down. I believe the linear piece is y equals 67.95x plus 11.1. All right, for now, I'm going to turn that graph off, and I'm also going to get rid of those points. And I'm now going to plot the points for the second piece, the piece I think is cubic. Looking at the data, again, I can really see that cubic graph here. We saw it in the bar graph, but is even, I think, more apparent when I look at the data plot. So if I think I can use a cubic regression on that, that would be y2, my second table, tilde, and then my cubic function, ax2 to the third plus bx2 squared plus cx2 to the first plus d. Again, I can see a pretty good fit here. And once again, my r-squared is very good, right? Almost 0.98. So a really good fit. And they've given me the parameters here. So again, I'm going to write down my function for my cubic piece is 1.259 x to the third minus 22.705. I'm keeping 3 decimal places here. That would be x to the second, plus 111.865. That'll be x to the first, and then plus 57.974. All right. So I just jotted down what I needed from those two regressions. They both were good fits. And if I now translate this into my tablet sales, let's see. T was years after 2010. I'm going to use M for market, it doesn't matter, M for market growth, but it's actually tablet shipments. And this is in millions. Then my function is going to be M of T. So the correct mathematical notation for that would be 67.95 T plus 11.1, and that's valid when T is from 0 to 3. And then my second function, all of this, and that's valid from 3 to 10. Now we've talked a little bit about this before. It doesn't really, we actually use that t equal 3 value in both of our regressions, so it doesn't really matter where you include the 3. Pick one, it's fine. All right, I'd like to go ahead then and I'd like to graph that piecewise function on Desmos and see how that fits my overall data. So I'm going to turn all of the data back on. Right? There was the piece I felt was linear, there was the piece I felt was cubic, and I'm going to enter my functions now in their piecewise form. So first I had y equals 67.95 t plus 11.1, and I only want that from 0 to 3. Again, the less than versus the less than or equal to in Desmos is so minor I'm not even going to bother with it. And we can see that's a really good fit for those first points. Make that a different color, I think, though. All right, and then my second piece of my function, the cubic piece. There that is, and that is valid from 3 to 10. And you can see there are the two pieces of my function. They don't quite match up, although on the graph they kind of do. And again, that's pretty typical, right? But we can see that overall, those two pieces do a really good job of modeling the data that I have. All right, I wanted to take a look at, I guess we have a blank page here. I wanted to take a look at one other graph. We don't have enough exact values here to actually do our regression, but I just wanted to talk about the shape and talk about some options here in terms of how we might choose to make a piecewise function. There's not always one specific way, but here I'm looking at this and I'm thinking, this first section, although it's not going to be perfect, I kind of believe that probably linear for that first piece is going to be my best bet. Now there's a section in here that looks a bit like a parabola to me. I could try and see if I could get a whole cubic function out of it, but this is a pretty sharp turn here. These two pieces look pretty straight. So I'm kind of thinking that maybe it's not curved enough in there to actually make a cubic function. I might be better off just going quadratic through here. Then the next section looks very linear to me. Right, there's this sudden, pretty linear downward trend in home ownership rate. Probably linear again. And then right in the late 2010s, right between 2015 and 2020, we suddenly have another sharp uptick. So perhaps yet another linear function here. So if I were actually going to model this, I would probably do it with 3 linear functions and then that one quadratic in there. At least that's what I would try first and see how well my data fits, my model fits those data. Like I said, we don't have enough exact values here to actually put values into Desmos, but just to kind of guide your thinking and how these things might look, I wanted to take a look at how that one might be done. All right, your next project will actually be similar to these problems. You'll be taking some data and you'll have your choice of all of the different polynomial functions that we've used. Linear, quadratic, cubic, quartic, and I'm going to say that's probably as far as you'll need to go. So first, second, third, fourth degree. And you'll be using those types of functions to model data that we give you in project number 2.